Could intelligent life thrive in the swirling storms of a gas giant? It's a question that challenges our imagination and pushes the boundaries of what we think is possible. For centuries, we've gazed up at the giant planets in our solar system, wondering if anything could survive in their immense churning atmospheres. We usually search for life on rocky planets, places with solid ground and familiar conditions. But what if we're looking in the wrong places? What if the most extraordinary forms of life are hiding where we least expect them, high above the clouds in the endless skies of gas giants? The universe is vast and surprising. With billions of stars and even more planets, the possibilities for life are almost limitless. Every new discovery reminds us that nature often defies our expectations. Gas giants like Jupiter and Saturn might harbor life in forms we can barely imagine. Their thick, colorful clouds and powerful storms create an environment unlike anything on Earth. Recent discoveries show these worlds aren't just hostile, they have atmospheric layers with surprisingly mild temperatures and key ingredients for life, like water vapor and methane. In some regions, the pressure and temperature could be just right for complex chemistry to unfold. Imagine life not on a surface, but floating in endless skies, adapting to a world with no ground. Creatures could drift on powerful winds, feeding on chemicals in the clouds, evolving in ways we've never seen before. Jupiter's Great Red Spot is a storm larger than Earth, raging for centuries. Within such colossal tempests, could there be hidden ecosystems protected by swirling walls of gas? Could there be oases of stability within this chaos? Calm patches where life could take hold, shielded from the most violent winds by layers of clouds above and below. The same laws of physics apply everywhere, but the ingredients and environments differ. Life, if it exists here, would be shaped by forces and chemistry unique to these alien worlds. Exploring gas giants expands our search for life. Probes and spacecraft are beginning to dip into their atmospheres, sending back data that could one day reveal signs of the unimaginable. Instead of limiting ourselves to Earth-like worlds, we're learning to look in unexpected places. The more we explore, the more we realize that life could take root in environments we once thought impossible. The journey into a gas giant's heart is a journey into the mystery of what life truly is and where it might hide. As we peer deeper into these alien clouds, we're reminded that the universe is full of surprises, waiting to be discovered. To imagine life here, we must first step back and consider the sheer scale and mystery of these worlds. When we look up at the night sky and spot the faint glow of Jupiter or Saturn, we're seeing planets that dwarf Earth in every way, colossal spheres of gas swirling with storms and secrets. To truly understand what it would mean to exist here, we must first understand the planet itself, its structure, its atmosphere, and the forces that shape it. Gas giants are made mostly of hydrogen and helium, with no solid surface, more like failed stars than oversized Earths. Their immense gravity holds on to thick, churning atmospheres, creating a world that is both beautiful and hostile, with bands of color and storms larger than our entire planet. Their atmospheres are deep, with temperatures and pressures that change dramatically with depth. The further you go, the stranger and more extreme the environment becomes, with each layer presenting new challenges and mysteries. At the cloud tops, it's freezing cold, with temperatures plunging far below anything we experience on Earth. Here, sunlight is weak, and the air is thin and frigid, whipped by powerful winds. But deeper down, heat and pressure rise to extremes. The atmosphere thickens, storms rage with unimaginable force, and the environment becomes more alien with every kilometer you descend. Somewhere in between there's a layer where temperatures are just right, neither too hot nor too cold. This habitable zone floats in the sky, a narrow band where the conditions might allow for the possibility of life. Pressure increases rapidly as you descend, reaching levels that would crush any earthly spacecraft. The deeper you go, the more the atmosphere presses in, until even the strongest materials would be flattened like paper. These conditions force atoms and molecules into exotic states, creating a truly alien world. Here, matter behaves in ways we can barely imagine, forming new materials and phenomena unique to these giants. Life here would have to be radically different. Creatures of the air, forever suspended between the void above and the crushing depths below. They might float, drift, or swim through the thick atmosphere, never touching solid ground. Navigating this world means mastering winds, updrafts, and downdrafts with no ground to land on. Survival would depend on adapting to constant motion, fierce storms, and ever-changing skies. The anatomy of a gas giant is a blueprint for a new kind of existence, one where life must adapt to a world without land, where the only home is the endless sky, and where every moment is a dance between gravity, pressure, and the unknown. The extreme pressures inside a gas giant transform chemistry itself. Imagine an environment so intense that the very rules of chemical reactions are rewritten. Deep beneath the swirling clouds, atoms and molecules are forced together in ways that simply can't happen on Earth's surface. On Earth, most reactions happen in water at moderate pressures, but in a gas giant, the crushing force of the atmosphere creates new possibilities. Here, familiar substances behave in unfamiliar ways, and new compounds can form that we've never seen before. Water, for example, can exist in supercritical states, neither truly liquid nor gas, allowing it to dissolve materials and drive reactions that are impossible under normal conditions. This supercritical water acts as a powerful solvent, opening doors to exotic chemistry. Lightning storms, common in these thick, turbulent clouds, provide bursts of energy that can break apart molecules and spark new ones into existence. It's a natural laboratory, echoing the famous Miller-Urey experiment that produced amino acids, the building blocks of life, on early Earth. The atmosphere of a gas giant is a planet-sized laboratory, running these chemical experiments continuously for billions of years. Every storm, every flash of lightning, is another chance for new molecules to form and interact. High pressure isn't just a barrier, it could be the key to forming life's building blocks. Under these conditions, simple molecules might be squeezed into more complex forms, setting the stage for the emergence of life. The real challenge is whether these molecules can organize into self-replicating structures. Molecules that can copy themselves, evolve, and eventually give rise to something we might recognize as life. Chemistry here isn't a dead end. It's a different path to life. The unique conditions of gas giants could foster entirely new forms of biochemistry, unlike anything found on Earth. Life might begin not in a calm pond, but in the dynamic, high-energy clouds of a giant planet, where chemistry is always in motion and the possibilities are as vast as the planets themselves. How could life survive here? In 1976, Carl Sagan and Edwin Salpeter imagined a gas giant ecosystem. At the bottom, tiny sinkers, microscopic life falling toward the depths, reproducing before being destroyed. Floaters, enormous balloon-like organisms, would drift in the temperate layers, feeding on organic molecules or producing energy chemically. At the top, hunters, agile predators navigating the atmospheric currents in search of prey. This food web would be perfectly adapted to a life of permanent flight. Buoyancy is the key. Just as jellyfish float in water, these creatures would float in air. The challenge: staying aloft in turbulent winds, either by being light or actively controlling altitude. Life here would be a breathtaking balance rooted in physics and biology. It's a vision that turns a barren world into a living sky. For life to exist, it must find a habitable zone, not by distance from a star but by altitude. Too high and it freezes, too low and it's crushed and vaporized. The Goldilocks zone is a narrow band where temperatures and pressures allow liquid water to exist. On Jupiter, this layer lies 5,100 kilometers below the cloud tops, with pressures and temperatures similar to Earth's surface. Here, water-ammonia clouds could create a stable, life-friendly environment. The challenge: staying within this narrow band, avoiding deadly updrafts and downdrafts. Life might regulate buoyancy or simply produce vast numbers of offspring, hoping some survive. This stable temperate layer is a cosmic oasis, turning a violent world into a potential cradle for life. Life needs energy, but sunlight is faint deep in a gas giant's clouds. Instead, life could harness chemical energy, chemosynthesis, using the planet's rich mix of hydrogen, methane, and ammonia. Earth's deep-sea vents offer a model bacteria there thrive on chemical energy, forming the base of unique food webs. Gas giant life could do the same, using abundant atmospheric chemicals as fuel. The sheer scale of a gas giant means immense total energy, even if it's diffuse. The entire habitable layer could be a source of fuel, not just a few sunny spots. This changes our view of what makes an environment energy-rich. Even rogue planets drifting without a star could harbor life powered by internal heat and chemistry. The universe might be filled with living worlds running on principles rare on Earth. Life here would exist thousands of kilometers above anything solid, closer to space than to the planet's core. Imagine a world with no ground, just endless sky and clouds above and below. For these organisms, down means danger. Their entire existence is about staying afloat. This three-dimensional life would be shaped by the need to avoid sinking into the abyss. The deep atmosphere shields life from cosmic threats. Asteroids burn up, and strong magnetic fields block harmful radiation. Life here would have no relationship with solid ground. Its world is wind and cloud. It's a humbling idea, challenging our earthbound perspective. Life could be thriving in places we've barely begun to look. How could life evolve in such turbulence? Gas giant atmospheres are in constant motion, with winds over 600 kilometers per h. This chaos could actually drive evolution, mixing molecules and increasing the odds of life's emergence. Only structures that resist being dragged down or flung up would survive, favoring buoyancy and resilience. Intelligence might evolve differently, perhaps to outwit prey or communicate in the vast cloudy expanse. The drivers for intelligence could be unlike anything on Earth. Evolution here would favor mastery of a three-dimensional fluid world. Life is tenacious. Once it starts, it adapts and diversifies, even in the wildest environments. The storms of Jupiter could be the ultimate evolutionary crucible. Considering life in gas giant clouds forces us to rethink what habitable means. The classic habitable zone is Earth-centric, assuming life needs a surface and sunlight. Gas giants suggest habitable zones can exist within planets, powered by internal heat. Even rogue planets, once thought dead, might nurture life in their warm, thick atmospheres. We should look for strange chemical imbalances in gas giant atmospheres, potential signs of life. The cosmos may be more creative than we imagine, with life emerging in unexpected places. The universe isn't obliged to fit our expectations. The most profound discoveries may await in the clouds of giants.